Hello and welcome. In this video, we are going to solve 10th problem of Leetcode, that is regular expression matching. So in this problem, we have given to a string s and p, and we have to implement regular expression matching with support of dot and star, where dot can match any single character and a star can match 0 or more than 0 any number of character of the preceding element. So let's see what does it mean. So let's say we have given a input s equal to a for first and p equal to a. So s is the string and p is for pattern. So we are given a pattern and we have to match whether this pattern can be matched with this string or not using this dot and star. So you can see there is no any dot or a star. So obviously this one cannot be matched. So you can see that if there was any dot or a star, then it can match with this and a can match with a. So there is no dot or a star. So the first for first input the output will be false. Okay, moving towards input 2. So in input 2 we have given input s equal to ab and p equal to dot star. So you can see that star means 0 or more of the preceding element. So for star the preceding element is dot, so there can be ab and it can also be a empty star, or it can be empty star and it can be dot star, it can be dot star, and it can also be dot star. So we can create any number of dot as we want, just to match our string. So you can see that it at this point a can be matched with dot and b can be matched with dot, as it is given that dot can match any single character. So this can match and our output will be true. So let's see the another test case, the test case number 3. So we have given input a and a star. So you can see that a star means we can create any number of a as we want. So we can get 0 number, 1 number, 2 number. So if we are creating 2 number of a, then you can see that a can match with a and another a can match with a. So this is going to return true. So okay, the last test case that I have written down, let's check out that. So we have input a c, a b, and a pattern dot c dot a star. So okay, dot can match with dot c dot a star. So dot can match with a and c can match with c. Now we have a b and dot star remaining. So let's see how we can match this. So you know that dot can be written as many times as we want, as it after that there is star. So it can be written as ab dot a star, and it can also be written as AAB dot a star. So dot can be matched with A and another dot can be matched with A and another dot can be matched with B. So this is going to return true. Okay. So how we can solve this problem? We can solve this problem using recursion or dynamic programming. So if you have to apply recursion, first we have to understand it. So we can understand it using decision tree. So I'm going to draw the decision tree for the same test case, and after that we'll be writing the pseudocode for recursion, and then we'll apply memoization on that problem and we'll be able to write the code for dynamic problem. Okay, so let's say our I is here and j is here at beginning. Okay, so we are making decision tree. So you can see that a can be matched with dot, so we don't have any choice. We have to make we have, we have to match this, and again after that we have to move our pointer by one, both I and j. So you can see that in this case we are moving our pointer by I plus 1 and j plus 1, and then you can see that c can be matched with c. So our string will be ac, and here we are moving our pointer I plus 1 and j plus 1. Now you can see that uh, next character of p is a star, so we have to take care of that, and our current character is in our current character in s is a. So we have here we have two choices, either we can keep this star or not. So if we are keeping this star, then it is going to be something like a c a, and in this case we have to move our I with 1 and we are not moving our j character anywhere. So you can see that we are moving I with 1 and j with 0 in this case. Again, if you are not using this, that it is going to be AC for now, and you know that it is not going to give any output, so we are not exploring this part. Now we are exploring this part. Let's see. So again, we are having two choices, either we can keep the star or we, we can't keep it. So if we are not keeping it, it will be going to ACA. If you are keeping it, it will be able to match the next character A, and we can move our I to next, and then it will be going to A C A A, and in this case you can see that we are moving I plus 1 and J as it is. So again we are having two options, either we can move use a star or not. So in this case, if you are using a star, it will be A C A B, and we are moving our character by 1, I with 1 and J with 0, and if you are not using it, it will be A C A, and then as we have exceeded all the indexes of S, we can't move our I, we will be moving our J. How, how many times we have to move it? We have to move it by two indexes, like we have to move the dot and a star also. So after moving two indexes, it will be covered all the indexes, and in this case we will be not using the star. So if you are not using the star, it will be AC AAB, and which is the string that we have to match, and it will going to return the true. Okay, so in this case you can see that we are doing I and j plus 2. Okay, so using this decision tree we are going to write the code for recursion. So let's go. So first we are creating a helper function where helper will be getting s p I and j, and every time we will be calculating the value of m equal to s dot length and n equal to p dot length. Okay, and then we will be if checking the corner cases, if any of m, any of I or j is reaching the last index, then we have to return true or false based on that. So if j is greater equal to n, we will be returning whether I is equal to m or not. Okay, now we are checking the current character equal to the current character of p, so p dot j. So there can be two cases, either the next character is a star or the next character is not a star. If the next character is a star, then we can check it by using p j plus 1 equal to a star or not. So as we are checking the j plus 1 index, we have to make sure that j plus 1 is lesser than n. Okay, and there can be one case which will be there can be one case there will when there is no star. So in this case we will be checking whether si is equal to current character or si equal to dot, as we can match any character with single dot. Okay, any single character with dot. So in this case we will be returning something. What we have to return, let's check. So in this case you can see that we are returning I plus 1 and j plus 1. So obviously s p I plus 1 j plus 1. Okay, and none of the case is satisfied, then we have to return false. Okay, so coming back, in if case, if the next character is a star, so if the next character is a star, then in the last case you can see that we will be checking whether helper of I s I s sorry helper of I s p I and j plus 2. If it is true, then we have to return true. Okay, and then there will be a case if current character is dot, like we can see that current character is dot and or current character equal to s of I. So in this case, you can see that we are moving our I plus 1 and j. In this case, you can see these are the cases. So in this case, we are moving helper of s p I plus 1 j. Okay, as we are checking the index of I, we have to make sure that I is lesser than m. Okay, so this is the pseudocode for recursion. Let's write this in compiler and check whether this is correct or not. Okay, so let's go to the compiler. Okay, so at first we will be creating a helper function. It will be a private where we will be taking a string s and a string p and the current index I and j. First find out the length m equal to s dot length and n equal to p dot length. Okay, now we have to check whether any of the corner cases. If j equal to n, then we will be returning whether I is equal to n or not, I is equal to m or not. Okay, now after that we have to check the current character ch cur equal to p dot char at j. Okay, so the case where next character is a star, so for that we will be checking j plus 1 should be lesser than n and p dot char at j plus 1 equal to star, and the else case will be I should be lesser than m and s dot char at I is either cur or s dot char at I, sorry, s dot char at I is either current character or cur is equals to dot. In this case we will be returning helper of I plus 1 j along with s and p. Okay, so if none of the case is true, then we will return false. And if the next character is a star, then we have to check two cases. If helper of I j plus 2 and s and pl. Okay, in this case we will be returning true. We have already discussed that this case. And if helper of, okay, so let's go back to the case for this one, like I plus 1 and j. When we have to do I plus 1 j, when there will be case like current character is either dot or the next current character is matched with the s of I. So in this case, if I lesser than n and s dot char at I is current or cur equal to dot, so in this case we will be returning we'll be checking again whether helper of s p I plus 1 j, then we'll be returning true. Okay, here we have to check. In this case we have to again, sorry, yeah, so I think we are done. Let's see, run this. No, first we have to call this function. For that we'll be calling it from here sp, and current index is 0 0. Now run this. Okay, we have to mention the return type and name of function, that is helper. Now run this. As we are calling it but not returning it, so return. Yeah, so first test case has been passed. Check the other remaining test case. All the given test case has been passed. If you are submitting this, I think it can give TLE. Okay, so it is giving the wrong answer for C star A star B. Let's see whether we have to make any changes or not. Yeah, yeah, here we have to send I plus 1 and J plus 1. The last case, you can see this one. No problem. Run again. Now submit it. It's showing pending. Let's see what happens. I think it can give really no. So a string index out of bound exception at line number 9. So we are checking. Yeah, it should be checked with I lesser than m. My bad. Yeah, so it has been accepted. I was expecting that it will be going to give TLE, but it is accepted. So let's see. Okay, now change this problem into memoization. So we have already implemented the recursion part, so we have to just implement the memoization on this recursion. So for that we will be using a boolean array of name dp new bool. So let's quickly initialize this. It is going to be of size s dot length plus 1 and p dot length plus 1, and whenever we are calling the function, just send this and change all the function call accordingly. And as we are sending this, we have to receive, so let's receive this. Yeah, and at the beginning we have to check whether our dp of I j is not equal to null. So if it is not equal to null, that means this, for this I and j, solution has been calculated already, so we don't have to do any calculation, just return the dp of ij. And whenever we are returning any value, just store it on dp of ij and copy this and paste whenever we are returning any value. Yeah, now run this. It's time to submit. submit this. Yeah, so you can see that our solution has been accepted, and it is too much faster than the previous one. And I hope you must have learned something from this video. In this case, please make sure to like the video, subscribe the channel, and if possible, please share the video among your friends. Thank you.